Okay, well, I guess we will get started. Can you hear me okay too? It's hard for me to see the chat. Okay. All right, so this is, oh goodness, now I can't remember which section it is. Oh yeah, because I'm going to skip past some of the stuff. So 6.4, solving quadratics that are quadratic in form. And so when we say something is quadratic in form, we're saying that the standard form looks like this. This is a squared plus b squared plus c equals 0. So what it means to solve a quadratic equation is that you're trying to, you're solving for x, but that means that you're finding the x-intercepts. So we can end up with imaginary solutions because parabolas aren't always going to cross the x-axis. So we've talked about 4 different methods that we can solve quadratics. We've talked about factoring. We've talked about the square root property. We've talked about completing a square. And we talked about the quadratic formula. So these are the different ways that we can solve quadratics. Sorry about that. Tickle in my throat. All right, so when we're trying to solve equations that are quadratic in form, like we're doing in this section, then they follow a pattern that looks like something squared. So it's like, so we've got this a times something squared plus b times that same something. Oops. I'll just put x on both of them. And then plus c equals 0. So these two things need to be the same that are in the parentheses there in order to solve this. So let's just review over how we would solve something like this one. So if we were trying to factor to solve it, right, we're thinking what 2 things multiply to be 12 that add to be -7. And so x times x is our x squared. 3 times 4 is 12, but also -3 times -4 is +12, and that would add to be -7. And then we can set both of those parts equal to 0 and solve, so we get x equals 3 and x equals 4 for my solutions there. So that's where it's crossing the x-axis. Now, on this next type, right, so we've got this x to the 4th minus 7x squared plus 12 equals 0. And I just want you to look up here and see, like, what is the same, what is different about these 2 things? All right, well, we can see that our coefficients are the same on all of them. We've got a 1, a -7, and a 12 on both of them. However, our exponents are different, right? We've got x to the 4th power and x squared on that second one, where on the other one we have x squared and just x. So, so looking at that, we're thinking, okay, well, how could I rewrite the first term so it has an x squared in it? So if I am trying to rewrite that, I could say, well, x squared squared gives me that x to the 4th, right? And so then if I rewrite the rest of it, I'd have -7, and then I'm going to keep that x squared in parentheses there, plus 12 equals 0. So remember, when we have a power raised to a power like this one, right? X squared squared, that's really x to the fourth, which is what we're looking at there. And remember I said the highest exponent is telling us how many
about 7 if you want to go upstairs.
answers. Oh, you unmuted yourself. So yeah, so that's telling us we're going to have 2 solutions, where this one's telling us we're going to have 4 solutions. Okay? So now, so we're going to be doing something called U substitution to solve these. And so when we're doing this, we're going to let U equal whatever the stuff is on the inside, right? So these two have to match when we rewrite it. And that's what we're going to let U equal. So we're going to let U equal x squared. Right? So then if I write this equation now using U substitution, so I'm going to, everywhere I see the x squared, I'm going to put a U in place of it. Okay, so I've got U, and then all squared, minus 7, and then again, where that x squared is, I'm going to put a U, right, plus 12 equals 0. So now that looks really similar to what we had at the beginning here, except we had x's in this one up here, where now we have u's in place where those x's were. So we're going to just go ahead and solve this for using this U substitution. So the reason why we're doing this is because we're trying to make it easier for us to factor to be able to solve it using this method. But if we take like x squared out and put the U in it, then we're going to have to put that x squared back in at the end. So can't forget to do that. Okay, so on this one though, if we factor it, got U and U, and then what times what is 12? That adds to be -7, -3 and -4. And then set both of those equal to 0 and solve, I get U equals 3 and U equals 4. Okay, however, I'm not done because I solved for U, but remember I had x's that I was trying to solve for before. So I need to make sure that I put that that back in, right? I gotta remember I said I'd let U equal x squared is what I did. All right. So if we look at this, the solutions from number 1, the same solutions to equations of this, right? Well, they both came out to be 3 and 4. And we already kind of talked about we should get 2 solutions because that highest exponent is a 2. Right? However, for this next one, since our highest exponent is 4, we should get 4 solutions. Okay? So now let's go ahead and put that x squared back in and see what you come up with here. So if I take these u's here, and in place of those u's, I'm going to put x squared. So I'm going to have x squared equals 3, and I'm going to have x squared equals 4. All right? And then we talked about solving those, right, using that square root property, because we have that x squared part by itself. So if I square root, both sides here, then on this first one, I get x equals plus or minus, can't forget that plus or minus part, square root of 3. And here, when I square root both sides, I get x equals not just 2, but plus or minus 2. All right, so remember, I have 4 solutions here. I have a positive square root of 3, a negative square root of 3, a positive 2, and a negative 2. And I'm expecting to have 4 solutions because my highest exponent was a 4. All right, and then you could go back and check those solutions for that. Okay, let's look at another one here. So on one like this, remember, like I said, we just need to make sure that the stuff inside right, is the same on, on both of those parts. And on this one, it's nice because it is the same, right? So we're going to put u in place of where we see that -5 minus 2. So when I do that, I've got 15. Actually, let me, yeah, 15. And then in place of that -5 minus 2, I'm going to put u, and then I still have that squared there. So 15u squared plus 4u, and then minus 4 equals 0. Okay, and now we can factor this to solve it. So remember on this, since our leading coefficient isn't 1, we've got that 15. We've got to do a little bit more to do with our factoring, right? So let's do our 15 times -4. That's going to give us -60. So what multiplies to be -60 that adds to be 4? So we'd want to just kind of list out our possibilities there and see what we could come up with, right? I mean, you know, it's going to be something that's kind of close together. Let's see, then, whoops, I guess 5 and 12, and then 6 and 10. And it looks like 6 and 10 is going to be the one that we want, right? Because if I have a -6, -6 times 10 gives me the -60, and -6 plus 10 gives me that +4. All right, so let's write this down as a 4-term polynomial. So keep that 15u squared the same, but 4u is going to be, change this to be plus 10u, and then minus 6u, and then minus 4. Then we can do factor by grouping. And so on this first one, we're looking to see what we can take out there. Looks like we can take a 5u out of both of those, and that will leave 3u plus 2. And then on the other one, since this is negative, we want to take a negative out with it. So it looks like a -2 is what we want to factor out, leaving us with 3u plus 2. All right, now that's really good because these guys are the same, so that's the greatest common factor in both. So that goes in one parenthesis, and then the 5u minus 2 goes in the other parenthesis. And then I can set those equal to 0 and solve. So when I do that, 3u plus 2 equals 0, 5u minus 2 equals 0. Let's subtract the 2 over, and then we'll divide by 3. So u equals -2/3. That's kind of weird. All right, and then let's add the 2 over. So I get 5u equals 2. And then divide both sides by 5. So u equals 2/5. All right, but I solved for u, right? I haven't solved for x yet. So remember, if I take, like I put u in place of that -5x minus 2 to make it easier for me to factor. But now I need to put that back in, right? So let's do that. So I need to, I'm going to put in place of u right here, -5x minus 2 equals -2/3. And then the other one, -5x minus 2 equals 2/5. Well, I don't like dealing with fractions, so I'm going to choose to kill the denominator by multiplying both sides of this equation by 3. Right, we'll make those divide out. On this side, I'll have -15x minus 6 equals -2. Now let's add the 6 over to the right side. I get -15x equals 4. And then if I divide by -15, I get x equals -4 over 15. Okay, so there's one of my solutions. And then on the next one, since my denominator is 5, on this side. I'm going to multiply that by 5 to get rid of it, but if I do that on that side, I've got to multiply it on the other side as well. So those divide out, and that will leave me with negative 25x minus 10 equals 2. Let's add our 10 over. So we get negative 25x equals 12. Divide both sides by negative 25, so x equals negative 12 over 25. All right, and let's look and see, like, how many answers am I expecting to get here? Well, again, I'm always looking at that highest exponent, and on this one, it happens to be a 2. So I am only expecting to have 2 answers on that. Okay, and whenever I'm asked to solve something, I can always check it by plugging it back into the equation. All right, I'm not going to take time right now to do that, but remember that's always a possibility of something you can do on this. Okay, we did, this one was kind of like the first one that we did, so I'm going to skip that one and let you try that one later. But let's look at this one, because this one looks really kind of weird, right? So I'm trying to solve x minus 1 square root of x minus 2 equals 0. So remember, we want it to be in that form. It's like ax squared plus bx plus c equals 0. And right now, my first term doesn't have a squared in it, right? But think about what happens to that middle term, right? If I took that square root of x and I squared it, I'd end up with x, which is what I have here on my first term. All right, so this is how I want to start off my thing. So I'm thinking, okay, the square root of x all squared is just x. That's what this is. So let's rewrite that as the square root of x all squared. Okay, and then minus 1, I'm going to put this in parentheses, square root of x, and then minus 2 equals 0. All right, now it looks really crazy in there to try and solve this with the square roots in it. So that's why we're going to let u equal square root of x. Right, so do you see how I have that in both parts? It has to be in this term and in that term. And that's what we want to set it up as. And that will make it easier for us to factor this to solve it. So let's put u in place now. So I've got u squared minus 1u minus 2 equals 0. Okay, well, we go straight to hippobutts because the leading coefficient there is a 1. So u times u is u squared. What times what is negative 2? That adds to be negative 1. Excuse me. All right, so 2 times 1 is the only way we can get 2. And if it's a negative 2, then one of them needs to be negative. Since our middle term is negative, that means our bigger number needs to be negative. So I've got negative 2 and positive 1 there. And again, when we set those equal to 0 and solve, we get u equals 2 and u equals negative 1. But remember, I'm not done yet. I was trying to solve for x, but right now I have what u is. So now I've got to put this back in. All right, so I have to take what we said u is, and we're going to substitute it back here in place of those. So I get square root of x equals 2 and square root of x equals negative 1. All right, and then to solve this, all right, we've got to undo a square root, we square both sides. So that square root and square undo each other, so I'm left with x equals 4. And then here, when I square both sides, I end up with x equals 1. All right, but let's look and see, what is our highest exponent? What is the degree of this one? Well, it's in fact a 1 here. right? That x just has a power of 1. But we came up with 2 solutions. So that's telling me that one of it is an extraneous solution. So one of them is not going to work out for us. So on this one, we do need to make sure that we do a check to see which one works and which one doesn't. All right, so let's check our x equals 4 first. So I've got 4 minus 1 square root of 4 minus 2 equals 0. So I've got 4 minus 1 times square root of 2, or sorry, square root of 4, which is 2, minus 2 equals 0. And that is, in fact, 4 minus 2 is 0. So 0 equals 0. So that one's good. Let's do the other one. X equals 1. So I've got 1 minus 1 square root of 1 minus 2 equals 0. So I've got 1 minus, well, the square root of 1 is 1 times 1 is still negative 1 there. And then minus 2, does that equal 0? Well, no, I got 1 minus 1 is 0. And so I've got negative 2 equals 0, which is not true. So that means this is not a good solution, and this is the only one we want to keep for our answer. Okay, so it's really important to look at, what is that highest exponent? Because that's going to help you kind of double check and make sure that you have the right amount there. Okay, we'll try one more here. So on this one, these ones look kind of crazy because now we've got these fractional exponents. And again, remember, we want it in that form of ax squared plus bx plus c equals 0. Well, remember when we talked about fractional exponents and how we can change those to radicals? Right, now remember, this 2 is separate from that x to the 2/3 power. Right, so I've got 2, and then x to the 2/3 would be the third root of x all squared. And so can you see now we have it kind of in that form, right? 2 is like the a part there, and then the rest of that is our x squared part. Well, let's rewrite the other one too. So minus 9, x to the 1/3 power is the cubed root of x, right? And then plus 4 equals 0. So now I've got cubed root of x is both of what's inside there. So this means it would be really easy to use u substitution to solve it. So we're going to let u equal the cubed root of x. So everywhere we see a cubed root of x, let's put u in place of it. So I've got 2u squared minus 9u plus 4 equals 0. All right. Well, 2 times 4 is 8. So what multiplies to be 8 that adds to be negative 9? Well, we've got to have 8 and 1, but both of those would need to be negative in order for that to add up to be a negative 9. And so let's write this out. So 2u squared minus 8u minus 1u plus 4 equals 0. Let's split this in half. So on this next part, 2u is our greatest common factor of those first two terms, leaving u minus 4. Okay, now look what we have left here, right? We got a minus u plus 4. It looks kind of similar to what we have here, right? But we need to factor a negative 1 out in order to get those to look the same. So if I factor a negative 1 out, then I'll have u minus 4 equals 0. Okay, so there's my greatest common factor. The u minus 4 goes in one parenthesis, and then 2u minus 1 goes in the other parenthesis. So set those equal to 0 and solve. I get u equals 4. And on this one, add the 1 over and then divide by 2. So I get u equals 1/2. And again, you can just take those steps to do it, put it equal to 0 and solve. All right, but I mean, make sure you're really careful. Like, these are not your answers yet, right? We took out that cubed root of x to make it easier for us to solve this. Now we got to put it back in. So let's do that on this next part. So I'm going to put in place of my u's, right? I need to put that cubed root of x. So I'm going to have the cubed root of x equals 4, and the cubed root of x equals 1/2. All right, well, we've got a cubed root. To undo cube rooting something, right, we're going to raise it to the 3rd power. We're going to cube it on both sides. So that's what we need to do in these. Cube all of that. All right, the cubed and the cubed root undo each other, leaving x equals 4 times 4 times 4, which is 64. Right? So I'm doing 4, 3 4s multiplied together. And then here, I've got x equals 1 times 1 times 1 is just 1, and then 2 times 2 times 2 is 8. Right? And so then I'm left with these two solutions. And again, it's kind of hard telling when it's in this form what the exponent is, but when I change it to radical form like this, I can easier see that, yeah, I should end up with 2 solutions on that. And those are the 2 solutions I come up with. All right, and then we did one similar to problem 5, also up top, so I'm going to leave that one for you to do. All right, let's go to 6.5 now. And on this one, we're going to be talking about solving quadratic inequalities. And so when I'm thinking about inequalities, right, remember that just means that you have like a greater than or equal to symbol, you have a less than or a less than or equal to symbol. So we're going to solve these in a kind of similar way to what we did if they were just an equal sign, by trying to factor that quadratic. Because what we're looking, remember we said when it's equal, not greater than or less than, the equal part is where they're crossing that x-axis. Okay? But one thing that I want to make sure is clear, if you have a greater than or a greater than or equal to symbol, then you're looking at the graph that is above the x-axis. Because we're saying it's greater than or equal to 0. Well, this x-axis is our 0 here, right? And so if I had that inequality, then I'm looking above the x-axis. If it was a less than or equal to, then I'm looking at the graph that is below the x-axis. Okay. So looking at this one, okay, so use the figure to solve the inequality. F of x is less than 0. Right? So I've got this less than 0. Well, stuff that's less than 0 are negative numbers, or a part that is below the x-axis. So we're dealing with the parts that are below the x-axis, but we want to know which x values those correspond with. All right, well, -4, right, corresponds down here, -3, -2, -1. So I'm just trying to get you to see that it's all of this stuff in between those 2 points that we found. So they said, okay, well, 2, 0 is one of the x-intercepts there. -5, 0 is another x-intercept. So we're saying that is all of the x's between -5 and 2. So when I write that in interval notation, I have square bracket, -5 to +2, square bracket. And so that is the part of the graph, right? These are the x's that are going to make this graph go below the x-axis. That's what we're looking at there. Okay. So we're not going to be dealing with those two. So let's go on to this one. So on this one, we've got, okay, we're trying to solve the inequality. X squared minus 49 is greater than 0. So again, remember, since it's greater than 0, we're going to be looking at the stuff that's above the x-axis. So let me make sure that we remember that. I'm going to write that in there. Okay, but if it was an equal sign instead of an inequality, then we would factor this. All right, so here, what times what is -49? That adds to be 0, because there is no 0 term in there. All right, well, that would be -7 and +7. Okay, so these are telling us where our x-intercepts are. So our x-intercepts are going to be at x equals 7 and x equals -7, right? Or in other words, 7, 0 and -7, 0. So let's go ahead and graph those on here. Okay. And now if we look at this graph, right, remember when we talked about parabolas before, and we said if that first term is positive, then it's a right side up parabola. So I don't really care how far down this graph goes, but all I care about is just kind of thinking, all right, well, it's going to look something kind of like this, because it's going to be a right side up parabola, and it has to go through the x-axis at these 2 points. Okay? But now with the inequality, right, we want to know where it's greater than 0. Well, it's greater than 0, the stuff that's above the x-axis, right? So that's all of this part of the graph and all of this part of the graph. But we want to know what x values that is, right? Well, if I have 8, right, that's going to hit here. If I have 9, it's going to hit here. If I have 10, it's going to hit here, right? So do you see that it's going to end up being everything from 7 and bigger on my x's? And similarly, going the other way, right, I've got more x's over here, because that is the part of the graph that is above the x-axis, right, where all of these x's are. So when I write this down in interval notation, remember you always write interval notation from left to right. So how far to the left is this going? Well, it's going to go out to -infinity up to -7. But then that's not all, right? We don't want any of the stuff down here, right? Because this is all stuff that's below the x-axis. We don't want that part. But then there is more to our graph on the other side. So we'll put union, and then starting here, 7 over to +infinity. And that would be our answer. So really, when you're doing this, you're trying to figure out, okay, where is it crossing the x-axis? Then is my parabola right side up, or is it upside down? And that's going to help us figure out which part, which x values we're looking for there. Okay, let's try another one. And again, right, so this, is something all squared. So again, when we want to solve those, let's get everything over to one side and put the other side equal to 0. Right, so I need to start on this one by subtracting 2 over. So when I do that, I've got 2p squared plus 3p minus 2 is greater than or equal to 0. And then I need to factor this. 2 times -2 is -4. So what multiplies to be -4? That adds to be 3. Now, the only things that we can, get there, if we have 4 and 4 times 1, right? The way we can add up to be a 3 is if the 1 is negative. Right, so that's my winning combination, 4 and -1. So let's write this down as a 4-term polynomial, 2p squared. That 3p we're going to write as plus 4p and minus 1p, and then minus 2 is greater than or equal to 0. Let's split this in half and do factor by grouping. So we get 2p can come out, leaving p plus 2. And on the right side, let's factor a -1 out, leaving p plus 2. All right, so we've got p plus 2 in one parenthesis and 2p minus 1 in the other parenthesis. Okay, but remember, we want to know where our x-intercepts are going to be. Right, and that's when we put each of these equal to 0 and solve. So if I have p plus 2 equals 0, right, and then 2p minus 1 equals 0. I say x-intercepts, but we're dealing with p, but same kind of thing on this. So here we get p equals -2, and then here if we add the 1 over, divide by 2, we get p equals 1/2. Right, so let's make a little table, or just a graph here to do this. So let's first plot where those two are at. So I've got at -2. So we put some little out here. So -2 would be right there. And then 1/2 I'm going to put about there. Right, and again, my graph, that first coefficient is positive, so I know that this is going to be a right side up parabola. Let's see, different colors in blue. So it's going to look something kind of like this. And again, my vertex might be down a lot further than that, but it doesn't matter how far down it goes. We just know that the stuff in between -2 and 1/2 is going to be the stuff that's below the x-axis, and then the stuff that is above the x-axis, everything's kind of going out from it. But on this one, we wanted to know when it's greater than or equal to 0. So we do want the stuff that is above the x-axis. Right, so these are going up and out forever. So again, remember that's all of the x's this way, all of the x's this way. So then my answer on that in interval notation is going to be -infinity up to -2, and it includes 2, so let's put a bracket on that. And then, and I think I forgot to put those, these should have been brackets up here. Oh no, sorry, they weren't, because I didn't specify this very much. That doesn't have the equal to part on it. So really on these, it would have been better had I put like an open circle here to help me remember that those are in fact going to be parentheses, not brackets. Hopefully that makes sense, right? It has the equal to part like this one does, then it does include it. So we do have a bracket on problem 5. Okay, but then that's not all. There's more from 1/2 to +infinity. So that would be our solution on this. All right, so again, on this, you know, basically the steps for this is you want to find those zeros. So find those x-intercepts. That means that's the same thing as zeros. Those x-intercepts of it. And then, you know, make sure that you know, graph those zeros where they're at, where those x-intercepts are at. And then I didn't teach you this test interval. You will get to that more in 1050, but everything that we're dealing with this one is either going to be a right side up parabola or an upside down parabola. So using the little interval thing isn't necessary. You will see that on some of the videos in the textbook and stuff, they will use that interval you know, way of solving it. But I think the way that I showed you here is the fastest and easiest to understand. But if you want another way to look at this, you can look at some of those videos in this section in the book. Okay, so instead of that, I would say, you know, graph and decide above x-axis or below x-axis. Remember, that's because, you know, if it was above x-axis, that's greater than or equal to. Below is when you have the less than, so less than or equal to. All right, let's try this last one, and then I think we'll be done for the evening. Okay, so on this one, this is going to factor again, and we want less than or equal to 0 on this. So on this one, we want the stuff that's going to be below the x-axis. Okay, but let's get this factored. This one should be pretty easy to factor. 2 times 1 is 2, right? And then if I want a negative 1 in the middle, we need to have a negative 2 and a positive 1. All right, and then find those x-intercepts. We can call zeros as well. All right, so we got x equals 2 and x equals negative 1. So I'm in a graph. Let me make my little grid here. And let's graph those on there. Now we do have the equal to part, so they will be closed in circles this time. Right, so x equals 2. It's going to be right there, where it's the point 2 comma 0. And then x equals 1 is our x-intercept at negative 1 comma 0. So that is here. All right, and then again, all of these happen to be positive, so these are all right side up parabolas. And since it was a less than, we want below the x-axis. And so that's all of the stuff in between here, right? And our x values for that are all of those things in between, right, my parabola. So when I write this down, right, I want the stuff that's just in between here, because that's the part that corresponds with the bottom of this parabola. Actually, that kind of looks like a funny looking smile there. All right, so if I want the stuff between here and here, and I include, right, the endpoints, because it has the equal to part, it'll be bracket, negative 1, comma 2, and then bracket. So everything between negative 1 and positive 2 would be our answer. All right, well, that takes us there. Next time we'll talk about circles, and then we'll do a little bit of review for the exam, because remember the exam is coming up next week. So make sure if you haven't worked on a lot of your homework yet, get going on that and really reach out to me when you have questions on that. Okay. All right. Any questions you guys have?